Why does something always fall the moment you release it? Is it really being pulled by some invisible hand, or is there another process at work? In the energy filament theory, the real answer is much simpler. It's not a mysterious force pulling it down. Instead, the object is sliding down a tightened slope within the energy sea. Picture two paths in front of you. One is soft, sandy, and uneven, and the other is a smooth, tightly compressed asphalt road. If you walk or push something on the sandy surface, it feels tough. Each step you take fights against the shifting, loose sand. But on the asphalt, the same effort feels much easier. The surface is tighter and more structured, so it requires less effort to move. Now, consider the energy sea around a large object like a planet. Just as the asphalt road provides less resistance, the area around massive objects becomes increasingly tightened. As you get closer, the landscape gets more structured, like tight asphalt pads forming in the energy sea. Any object you release will naturally slide towards these paths, simply because they require the least effort or energy to traverse. That's gravity. The object is not being pulled by an invisible force. Instead, it's moving towards the most energy-efficient path, following the natural slopes created by the surrounding energy sea. When you hold an object in your hand, you're essentially keeping it on a rough terrain within the energy sea, fighting against the natural flow. Once you let go, the object doesn't experience some mysterious pull. It moves along the most energy-efficient path, sliding down the tight slope towards its west energy position. The object rolls like a marble on a smooth, downhill path, gaining speed as it travels towards the natural, west energy resting place. When you throw a ball forward, why doesn't it just fall straight down? Why does it follow a curved, parabolic path instead? Imagine you throwing the ball while adjusting the ground beneath your feet to slope downward, creating a subtle gradient. The ball, while trying to maintain its original forward momentum, is also influenced by gravity, causing it to slide along this new downhill path. The combination of these two forces, the ball's desire to continue forward and gravity's effect, results in the ball following a curved, parabolic trajectory. This is the motion you observe. Planetary orbits, such as Earth's path around the Sun, follow a similar principle. It's not that there's an invisible string tethering the planet to the Sun. Instead, the Sun's gravitational field presses the surrounding energy sea into a smooth, tightly wound surface, like the inner walls of a large bowl. A planet which is initially moving with a high lateral velocity finds it easier to follow this tight path and to continue in a straight line. This results in an orbit. The planet isn't being pulled by some invisible force. It's simply moving along the path that provides the least energy cost. The orbit, therefore, is the most energy-efficient trajectory for the planet in the energy sea. The same principle applies to you standing on the ground. Gravity doesn't pull you down directly. Instead, Earth's gravitational field creates a network of energy pathways that hold you in place, minimizing the energy required to stay upright. Your body, shoes, and the ground are all aligned along this optimal pathway. Standing still is the state in which the energy sea around you is in the most stable configuration, using the least amount of energy. Gravity isn't about an invisible hand pulling you downward. It's simply the energy sea surrounding you, offering the path that requires the least energy. In this understanding, gravity isn't a force acting from a distance. Instead, it's the result of the energy sea structure, with objects following paths that require the least amount of energy to maintain. When an object falls, it's not being pulled down. Rather, it's simply following the natural slope of the energy sea, where the total energy cost is the smallest. Everything in the universe, including planets and even light, follows these paths, shaped by the landscape of the energy sea. So, the next time you experience gravity, consider it not as a force that pulls but as a path to the lowest energy state. Gravity is a fundamental feature of the energy sea, guiding everything along the most energy-efficient path, from Earth's gravitational field to the orbits of the planets. Everything we see is simply following the natural slopes of the energy sea. Tap follow, share it on New Physics, Clear Universe.